Probability and statistics. This course is mainly focused for engineers, and we will cover almost all the topics related to probability and statistics, which are commonly applied in engineering, especially electrical engineering and communications. And we'll start from very basics and we'll go up to advanced level. So uh, we start our revision. First of all, we will see what sets are. A set is a collection of things. Uh, let me take the pointer over here first. Yes. A set is a collection of things. For example, A is a set of fruits, three fruits rather, banana, apple and orange. B is a set of three cities, Karachi, Lahore and Madrid. And C is a set of odd numbers 1, 3, 5, 7 and so on. The things in the set are called elements, like banana, apple and orange are elements of set A, Karachi, Lahore and Madrid are elements of set B, and 1, 3, 5, 7 and so on are elements of set C. Conventionally, we use capital letters to denote sets. A, B and C over here are denoting the sets, and small letters are used to denote elements. Now we'll go through some symbols which are very commonly used in set theory. This symbol over here, which is like E, denotes an element is part of a set. So how do we read it? For example, if you have got something written like this, X, and this symbol over here and A, then you will read it like this: X is an element of set A. Here this symbol is saying that this element X is this whatever this variable X, or not a variable, but this value over here is an element of A. And the same symbol with this cross line over here says that it is not an element of A. So C is not an element of A. This pipe or vertical bar means given that or such that. So here C is equal to is a set of all the values of x square, where x is equal to 1, 2, 3, 4 and 5. So this one is the function or operation, and the values of x are given here. So we read x square given that x is equal to 1, 2, 3, 4 and 5. And how do we get the set for C? We will simply plug in these values of x in x square, and we will get values for x square. So here square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, and square of 5 is 25. So here we have got a set C having elements 1, 4, 9, 16 and 25. Now A is a subset of a set B if every member of a set of A is also a member of B. And the symbol for subset is this one. This is the symbol of subset. Thus A is subset of B is a mathematical notation for the statement that the set A is a subset of set B. Now what is union of sets? The union of sets A and B is the set of all elements in A and B. It means that when we say A union B, we simply mean that we combine all the elements of set A and B in a single set. So for example, here we have A is equal to Umar, Jacob, Vijay, Javier, and B is Jennifer, Amna, Carmen and Nirmala. These are two sets. So the union of this A and B will be simply a set which comprises of all the elements of A and all the elements of B. So C is equal to Jennifer, Amna, Carmen, Nirmala, Umar, Jacob, Vijay, Javier, which are the elements of A and B. The set operation corresponds to the logical OR operation. The union also corresponds to the parallel system. So this operation, union operation of set, corresponds to the logical OR operation. So here you can see that S1, S2 and S3 are three systems which are combined in as parallel because it is OR system, and it is represented in set theory, it is represented by union operation. And intersection operation is like AND operation. As you can see over here, the set operation intersection corresponds to the logical AND function, and it also corresponds to the series system. And what is an intersection? For example, X belongs to A union B, intersection B, if and only if X is an element of A and X is an element of B as well. So if there is an element such that which is present in both the sets A and B, then that element will be part of the intersection set of A intersection B. Here you can see that this the graphical representation of this statement that the intersection also corresponds to the series system. Here we have shown you that S1 intersection S2 intersection S3 are combined in a series system over here. The complement of a set A, denoted by AC, A superscript C, is the set of all elements in S, which is a universal set. Universal set can be represented by S or U, that are not in A. The complement of a universal set S is the null set, and formally we can write it like this: X belongs to A complement C. A complement X belongs to A complement if and only if X is not an element of A. So suppose you have got a set over here, U is equal to 0, 1, 2, 3, 4, and A is a set of elements 0, 1, 2, and B having elements 0, 3, 4. So A union B will be simply the combination of these two sets. The thing to be noticed over here is that this 0 is present in both the sets, but it is written only once. So the elements which are common in the two sets are written only once when you are combining the two sets. And the second thing is that when you combine A union B, you can see that it is as same as this universal set over here, U. And A intersection B is only 0. Why? Because as you can see that only this 0 is common in both the sets A and B. All the other elements are different. So the elements which are the same or common in both the sets are part of intersection set. So A intersection B is 0. And complement of B. Complement of B means that all the elements which are not present in B, but they are part of the universal set. So here you can see this is 1 and 2. These two elements are not present in B. So this is the complement of B. Difference operation. It is a combination of intersection and complement. The difference between A and B is a set A minus B. How do you subtract two sets? This is what we see over here, that the difference of the two sets A minus B that contains all elements of A that are not elements of B. So formally we can say X is an element of A minus B, the difference of sets A and B, if and only if X belongs to A and X does not belong to B. So A is an element of A, but X is an element of A, but X is not an element of B. So A minus B is equal to nothing but A intersection B complement. So in this case over here, in this case over here, A minus B, how we'll calculate? This is B complement, and we have to take intersection of this B complement with A. So A is 0, 1, 2 and B complement is 1 and 2. So if we subtract or take the common elements from A and B complement, these are just the there are only two elements, 1 and 2. So the difference of A minus B will be 1 and 2. Mutually exclusive. A collection of sets A1 up to AN is mutually exclusive if and only if A I intersection A T is equal to phi, where I is not equal to J. I think there is some mistake over here. It should be J, not T. Anyhow, in simple words, two sets are called mutually exclusive if they don't have any common element. For example, A is equal to 2, 3, 4 and B is equal to 5, 6, 7. So these two sets are mutually exclusive. If you will take the intersection of these two sets, you will get a null set phi over here. It is representing a null set. So you will get a null set, and that will be it means there will no elements will be present in that set. When there are only two sets in the collection, we say that these sets are disjoint. So formally A and B are disjoint if and only if A intersection B is equal to a null set. So we can say that the two sets are disjoint sets. They are if the intersection of the two sets is phi or null. And a collection of sets is collectively exhaustive. This is mutually exclusive, and now we are talking about collectively exhaustive. A collection of sets is collectively exhaustive if and only if A1 union A2 union A, if you combine all the sets, then you get the universal set. So just as sum of all xi is a shorthand for x1 plus 2 up to xn, we will use a shorthand for unions and intersections of n sets. So here this big U I is equal to 1 to n ai shows that we are taking union of all the sets of A1, collection of sets of A, A1, A2 up to AN, and this is intersection of all the sets of A, and which is represented by I is equal to 1 intersection n AI. It means we are taking intersection of A1, A2 up to AN. Now here comes the most famous De Morgan's law. This De Morgan's law shows that the union, the complement of A union B is equal to the intersection of A complement and B complement. So proof is that suppose we have got an element X which belongs to A union B complement. That implies that X is not an element of A union B, of course, because it is complement. So X must not be an element of A union B. Hence X is not an element of A and X is also not an element of B. Together it implies that X is not an element of X belongs to A complement and X belongs to B complement. When you say that X is not an element of A, it means that it belongs to the complement of A. So X belongs is an element of A complement and X is an element of B complement. That is, X is an element of A complement intersection B complement. So suppose you have got a universal set up from 1 to 9, and then we have got a set A 2 5 8 and another set B is equal to 1 4 6 and 7. What will be the union of A union B? Simply 2 5 8 and 1 4 6 7. We put them together, so we get A union B. What will be the complement? Simple. The elements which are not present in this A union B. So there are only two elements, 3 and 9. 3 and 9 are not over here. You can see 3 and 9 are not present in A union B. So the complement of A union B is simply the elements which are not present in A union B. And complement of A is very simple. All the elements except 2, 5 and 8. So all the elements of U except 2, 5 and 8, which is 1, 3, 4, 6, 7, 9. And B complement similarly 2, 3, 5, 8, 9. These are the elements which are not present in B, but they are present in U. 2, 3, 5, 8, 9. So what is A complement intersection B complement? Here we take the intersection of these two sets. We find that there are only two elements, 3 and 9, which are common in both the sets. So we get 3 common ends. So you can see that here that this proves that De Morgan's law is correct, because with this example we get what we get from A union B complement is same as A complement intersection B complement. The result is the same.